Hello guys and welcome again. In this lecture we'll see how to use OpenCV to blend two images using the image pyramids. So suppose that we have an apple image and an orange image and we want to blend these two images to have the half of this image blended with the half of this image. If we do that using normal blending with numpy, we'll get an image like this one, where we have here like this line that separates the two half of this image, and we don't want this type of images. While with OpenCV we can get an image like this one, which look like a normal image, and we can't see here any line that separates these two half of images. So let's start and see how to do this using OpenCV. So first I need to create a Python file. I will call it blending images.py. I will import cv2 and numpy, and I will read two images from this folder here, this folder data. So the first one is apple image, cv2.imread data apple, and the second one is orange, cv2.imread data orange image. Let me show these two images, cv2.imshow apple as apple and cv2.imshow orange as orange, and then cv2.waitKey 0. Let's run this code, python blending images.py. So this is the orange image and this is the apple image, and we want to blend the half of this image with this half of the other image. I need to create like here a copy of each one of this image, so I will call it apple.copy. I will call it A, and B as orange.copy to work on these copies of these images without changing the original image. I need also to be sure that these two images have the same shape. So for that I need to say assert that apple.shape is equals to orange.shape. So now first let me show you how to do the normal blending. So in that case I can call an image normal blending, and it will be just numpy.horizontal stack of the A image, all rows of this image with, let me here create for example columns, rows, and the channels, I don't care about them, and then saying a.shape. So this will be from this till the half of these columns. So I will use this to forward slash to get the integer value, and from the B I want the from columns divided by 2 till the end. So I want the first half of this image and the second half of this B image. Let me show it here. So cv2.imshow normal blending, and then call it here normal blending, and if I show it, it will be like that. So see, this is the normal blending. We don't want an image like this which have this line in the half, and it is clear that it is a blended image. So now the image pyramids blending, image pyramids using image pyramids blending. For that we need to create first the Gaussian pyramids for the A image and also the Gaussian pyramids for the B image. So for the Gaussian pyramids, I will call them Gaussian pyramids of A and as a list, and the Gaussian pyramids of B as a list also. Let's start by A image. So the first element of this list will be the original image here, A, that we have created here, and also for B is the same, it's the first image. And for I in range of, you can choose any level here. For example, if I choose level as 5 levels, I want to work on 5 levels of this image. So for I in range of 5, then I need to create a new I, which will be so this A will be the cv2.pyramid down of the A that we have. At each time it will be changed, and A will be the pyramid down of the last A. So in that case I will say gpa.append that new A, and the same also for B. Just will change, instead of A I will put here B like that, and also here B, and also B here. So now we get the Gaussian pyramids of A and B, and we now need to get the Laplacian pyramids of A and B also. So for that I will come here and say the Laplacian pyramids of A and B. We will create also a list of Laplacian pyramids of A, which will be a list, and also Laplacian pyramids of B, it will be also a list. So the first element of these two lists will be the last element of this Gaussian list. So for that I will say GP, which will be the Gaussian pyramids of A. You can say 5, as we have here 5 elements, or you can just say -1 to get the last element, and the same here but with GP dot Gaussian pyramids of B with -1 to get the last elements. And for the Laplacian we'll go from I in range of, this time we'll go from 5 to 0, because we want the last element, we will work on the last elements going down to the first element. So till 0 here will be excluded, because the range is start from the first element included and the last element excluded with a step of -1. So it will start by 5 and then going to 4 till 1. We need to create the G Gaussian expanded, which is the opposite of Gaussian, which will be cv2 dot, instead of pyramid down like here, we will use pyramid up of the GP, which is the Gaussian pyramids of A, here in this case, of that I. So now we get the Gaussian pyramids of this I, and we did it pyramid up and then getting this GA. And to get the Laplacian, I will, for example, call it L, and then saying cv2 dot subtract of that GPA of I minus 1 with this GA. So these two images will have the same resolution as we get here the pyramid up, which will give us the up level resolution of this GPAI, which is the same as GPAI minus 1. And then add this to LPA dot append this Laplacian here. So let me call it also LA to have differentiate between it and LB. And we can do the same here for B also. So come here and change this. Here instead of A I will give it B, and here B like that, and here also B, and here B also, and here of course B. So now we get the Laplacian for A and B, and we need now to reconstruct the images to get reconstruct these Laplacian images to get the an image like what we want. So for that I will come here and I will create a list, for example call it ls, and this will be an empty list, and I will say for LA, which is Laplacian A and Laplacian B, in zip of the Laplacian of A and the Laplacian of B. Then I need to get the columns and rows of this and also the depth with one of this image because they have the same one, and each time I will have a new columns and rows or a new shape here. So shape, and coming here and saying the ls for this ls here, which will be np dot horizontal stack of these images. So first one is LA, all the rows with till the columns divided by 2, and LB, all columns, all rows and columns till, so columns from 2 till the end, and then add this ls dot append this ls like that. So now we get the list of these combined images. We need to reconstruct the last image that we want. So for that I will come here and saying ls combined, which will be the last element of this or the first element of this ls, and saying for I in a range of let's say 0 till or 1, because you get 0 here, till 6. So this 6 will be excluded. We have just till 5, and then so this means here for I in range of, then we will do the ls combined of cv2 dot pyramid up of that lsc, and then we will get lsc as cv2 dot add this lsc with the ls of I, and this lsc will be the image that we want. So if I come here and saying cv2 dot im show the pyramid image pyramid blending, so pyramid like that, blending, then say this lcc, and then we can run the code and see the result. So this is the pyramid blending that we want, and this is the normal blending, and we have here the original images as you can see here, with the normal blending without using image pyramids, and the blending using this image pyramid technique. As you can see, the difference is clear. This image looks like a normal image, while this image here is clear that we have combined these two, half of these two images. So it's always better to use the image pyramids to blend two images if we need if we need two images to be blended. It is better to use the image pyramids for that.